It's a bold idea in popular science. Maybe our universe was born inside a black hole. It sounds like something out of a sci-fi novel, doesn't it? Intriguing, even romantic. But when we look at this theory through the lens of energy filament theory, we see that this claim needs to be examined and broken down into crucial steps. First step, we reject the traditional Big Bang theory that suggests the universe started from a single, infinitely dense point that exploded. According to energy filament theory, the beginning of the universe didn't come from a singular point in space, but rather from an entire vast expanse of boiling, highly tense energy filaments. It wasn't an explosion but a state of extreme energy stretching, shearing, reconnecting, all happening in a chaotic, bubbling soup of energy. Second step, while we reject the idea of the Big Bang singularity, we also don't fully subscribe to the idea that black holes must inevitably create universes. The reason is simple: black holes, as we understand them, aren't the same as the origin of the universe. A black hole structure consists of 4 layers, and it operates as a localized, self-contained object. On the other hand, the birth of the universe is a global, all-encompassing event that affects the entire cosmos, not just a specific point in space. These two concepts, black holes and the origin of the universe, are not directly interchangeable. Now, here's where it gets interesting, and even a little risky. In energy filament theory, the material state of the early universe was not a cold, empty void but a vast, swirling sea of energy filaments. A black hole's core, on the other hand, can be thought of as a highly concentrated, tiny clusters of this same sea of filaments. So, in essence, both the early universe and a black hole's core share the same type of matter, but the only difference is the scale. One is expansive, and the other is highly concentrated. This observation leaves us with an intriguing possibility, a hook that we can explore but not yet definitively conclude. If, under extreme conditions, the event horizon of a black hole were to lose its stability, and the closure of the black hole retreats, leaving just the core of the black hole, could that core expand and evolve into an entire universe on a much larger scale? Here's what we know and are asserting for now based on energy filament theory. 1. We unequivocally reject the textbook interpretation of the Big Bang singularity. 2. We do not yet fully accept the idea that a black hole inevitably creates a new universe. 3. However, we are very seriously taking note of this. The material states of a black hole's core and the early universe's sea of filaments are fundamentally identical. As for the question of where the universe really came from and whether there is a deeper connection between black holes and the universe's origin, we will dive deep into this topic in future episodes. In fact, we'll dedicate an entire season, starting in episode 13, to fully dissect and explore this idea. For now, we'll leave this crucial hook here. In the next episode, we will be discussing: how does a black hole go through its life cycle? What happens when a black hole lives, evolves, and ultimately ends? Follow us closely as we continue to unravel the mysteries of the universe and delve deeper into the realm of new physics that challenges what we've been taught in textbooks. Tap follow, share it on New Physics, Clear Universe.